Welcome to this explainer. Okay, so if you've ever driven a manual transmission and, maybe nervously stalled it at a green light while everyone watched, you have actually engaged with one of the absolute most brilliant mechanical assemblies ever designed. Today, we're going to totally demystify exactly what happens right under the hood when you shift gears. We are looking at a true marvel of mechanical engineering, the Constant Mesh Gearbox.
Here's a quick look at our blueprint for today. We'll be running through 1. The gear grinding problem, 2. The anatomy of the gearbox, 3. How shifting actually works, 4. The pros, cons, and comparisons, and finally, 5. Applications on the road. Let's dive right in.
Before we get to the actual solution, I want you to vividly imagine something with me for a second. Think about that visceral, completely terrible noise of metal grinding violently on metal. If you were a passenger in a very early automobile, that horrific clashing sound is literally what you would have heard every single time the driver changed gears. It was a chaotic, noisy, and quite frankly, highly destructive experience. But why?
That brings us to Section 1, the gear grinding problem, or moving away from sliding gears.
So early manual transmissions were known as sliding mesh gearboxes, and structurally speaking, they were a nightmare. Driving wasn't just some leisurely Sunday cruise. It required this exhausting, highly skilled dance called double declutching, just to avoid completely destroying the transmission. Basically, to shift just one gear, a driver had to press the clutch pedal, move to neutral, release the clutch, rev the engine to perfectly match the rotating speed of the shafts, press the clutch again, and then finally force the lever into the next gear. If you missed that timing even slightly, well, you paid the price.
Here's the thing. In these sliding mesh systems, the gears literally had to slide axially along a shaft and mash into one another while spinning at totally different speeds. As you can probably guess, this caused continuous, massive frictional wear on the shafts themselves, and worse yet, because the gears were physically slamming into each other, catastrophic tooth breakage was a huge issue. It was just noisy, super inefficient, and it practically begged for a better way.
Moving on to Section 2, Anatomy of the Gearbox. Let's meet the heroes under the hood.
Right, so this entire setup basically relies on a trio of crucial shafts. First up is the clutch shaft. This acts as your input, pulling raw power directly from the engine. It takes that rotational energy and transfers it down to the layshaft. Sometimes you hear it called the countershaft, which is kept in a state of constant rotation. And finally, we've got the main shaft. This is the output shaft that actually grabs that configured power and sends it right on out to the wheels.
Now this is my absolute favorite part. Meet our hero component, the dog clutch. This little piece is the absolute genius of the constant mesh design. In the older systems, the big, clunky gears themselves did all the sliding. But here, the gears on the main shaft just rotate freely in place. They don't move back and forth at all. Instead, the dog clutch, which is splined to the main shaft, takes over the active role of shifting. It just slides left or right to securely lock those freely spinning gears onto the main shaft. And, well, because those gears didn't have to awkwardly slide into one another anymore, engineers could finally upgrade the gears themselves. They brought in helical gears. Because helical gears have teeth cut at an angle, they kind of engage gradually, rolling together, rather than slamming together all at once like the older spur gears did. This completely eliminated that horrible grinding noise, gave you an incredibly smooth operation, and let the whole gearbox carry much, much higher loads.
Okay, Section 3, how shifting actually works. Let's follow the journey of power.
Let's actually trace this journey of power. It's kind of like a relay race. It all starts at Step 1, where the engine turns the clutch shaft. In Step 2, that power jumps immediately down to the layshaft, which keeps all of its gears spinning constantly. And remember, the gears on the layshaft are in constant mesh, meaning they're always touching, with the gears on the main shaft right above them. In Step 3, when you move your gear lever, a selector fork pushes the dog clutch so it engages with a specific main shaft gear, locking it down. Finally, in Step 4, the power flows through that newly locked gear and blasts straight out the main shaft.
This right here brilliantly illustrates the actual physics of driving. Notice this inverse relationship. When you pop it into first gear, the dog clutch locks the largest gear on the main shaft, which happens to be driven by the smallest gear on the lay shaft. This gives you maximum torque to pull a heavy vehicle from a dead stop, but you get minimum speed. On the flip side, in fourth gear, you engage the smallest main shaft gear driven by the largest lay shaft gear. You completely sacrifice all that pulling torque, but in exchange, you get maximum highway speed. It really is the perfect mechanical trade-off.
But what if you actually need to go backwards? Changing a vehicle's direction doesn't mean you have to somehow make the engine spin in reverse. Actually, it's as simple as inserting a special extra gear called an idler gear directly between the layshaft and the main shaft. When the dog clutch engages the reverse setup, that single idler gear just reverses the rotational direction of the output shaft, and suddenly you're backing up.
All right, Section 4, Pros, Cons, and Comparisons. The evolution of the transmission.
When you put these two designs side by side, the evolutionary leap is just incredibly obvious. With the old sliding mesh, gears physically slam together, causing extreme noise, awful clashing, and rapid tooth wear. But with constant mesh, all the gears stay constantly engaged, relying entirely on those durable little dog clutches to do all the moving. It is vastly smoother, dramatically reduces wear on the gear teeth, and just offers a hugely improved driving experience.
Now, it's worth noting, while the constant mesh design was a massive revolutionary leap forward, well, it wasn't completely perfect right out of the gate. Because the gears on the main shaft were spinning at slightly different speeds than the dog clutch itself, a driver still needed pretty good timing to avoid clashing them. We actually wouldn't get the totally effortless shifting we enjoy today until modern synchromesh rings were added later on to seamlessly match those speeds before engagement.
But even with that early learning curve, this design was literally a game changer because the gears don't slide in and out of place. They remain in constant full surface contact. And that means the constant mesh design is just incredibly durable. It can handle immense punishing torque without stripping any gear teeth. Plus, because of the way the shafts run perfectly parallel, it is incredibly space efficient and compact.
Let's wrap up with Section 5, Applications on the Road, and where constant mesh lives on today.
If you step out of the garage today, you are going to see this robust, heavy-duty gearbox almost everywhere. Because it handles high torque and massive loads so effectively, it is absolutely the go-to for farm tractors pulling plows, heavy commercial trucks hauling freight on the highway, and massive construction machinery. And beyond that, because of its really compact footprint and its ability to execute super quick, positive shifts via those dog clutches, it's widely used in high-speed motorcycles and even heavily featured in the racing transmissions of performance sports cars. It really is just a phenomenal piece of engineering that completely revolutionized how we move. So I want to leave you with this final thought to ponder. Next time you hear a heavy truck pulling smoothly away from a stoplight, or you seamlessly shift gears on a motorcycle, who are you going to think? Think about those constantly spinning helical gears, those perfectly sliding dog clutches, and the brilliant mechanical heroes hidden right under the hood that make it all possible. Thank you so much for joining me for this explainer. Keep asking questions, and I'll see you next time.